Hello everyone, welcome back. Today we're not doing a lesson, we are just going over the proof help in this video. We have 8 proof helps that we are going to go through, starting with midpoint. The midpoint is just the middle of a line segment. So here, E is the midpoint of the segment AD. It is also the midpoint of segment CB. So in terms of having a flow chart, if we were given that E was the midpoint of AD, this tells us that the first section, AE, is congruent to ED because the midpoint cuts it in half. It's the middle. So this would be enough to say AE is congruent to ED. So when you see that you are given that E is the midpoint, you should be automatically thinking that that means that cuts a segment in half. Moving on to alternate interior angles, this one we should be uber familiar with by now. If lines are parallel, so in this case AB and CD, denoted by those arrows there, if those are parallel, then the alternate interior angles are congruent. So we have 2 sets of alternate interior angles. So if we were given that side AB is parallel to side CD, again, those 2 lines mean parallel, then that means that, for instance, angle ABC is congruent to angle DCB. Or we could do our other set of alternate interior angles if we wanted to. For instance, angle ACB is congruent to angle DBC. And the reasoning for either of these statements, you can say alternate interior angles are congruent. Moving on to angle bisector. This is a line that cuts an angle into 2 equal parts. So in this picture, we have angle D, and segment DB is an angle bisector, and so it is cutting this angle D into 2 equal parts. So BD bisects angle ADC. That means that we now have 2 equal angles. Angle ADB is this one in pink. That is now congruent to the green one, angle CDB. It just cuts that angle into 2 equal angles. And the reasoning, we could say this if we were given that BD bisects this angle, is simply just writing definition of angle bisector. Moving on to alternate interior angle converse. This is just our alternate interior angles, but remember the converse is when we switch the if and then. So here now we are starting with if alternate interior angles are congruent, then the lines must be parallel. So if we were given that ABD, that angle is congruent to angle CDB, then that must mean that sides AB and sides DC are parallel. The reason we can say this is because alternate interior angle converse. That's the name of this proof tactic. That would be our reasoning. Moving on to segment bisector. It is just like an angle bisector because to bisect means to cut into 2 equal parts, except instead of cutting an angle in half, we are cutting a side in half. So we have segment CB, and AB is cutting that in half. So we have 2 equal parts here. And that's exactly what we're going to say. That implies that segment CD is congruent to segment DB because it was chopped in half by AD. And our reasoning for this, we could simply write segment bisector, or definition of segment bisector. Vertical angles, we've been in on vertical angles since day one, try one. Angles that are across from each other, formed by and intersecting lines are congruent. So in this case, this is angle AEC, congruent to angle BED. And we would say this is because they are vertical angles. We'll come back to CPCTC, we'll hit that at the end. Reflexive property, we've talked about this already. Something is always equal to itself. So if we have a shared side right here, like AD, saying that it's the same as itself, AD is congruent to AD, our reasoning for that would be the reflexive property. All right, now CPCTC. This stands for corresponding parts of congruent triangles are congruent. That's a lot of words, but basically, let's say that I am the most beautiful person on the planet and I have a very symmetrical face. Okay, so my eyes are exactly the same, well, except they really don't look the same there. Let's say both sides of my face are perfectly symmetrical. Okay, if I were to prove that my left side of my face is equal to my right side of my face, wouldn't I also be able to say then that my left eye is congruent to my right eye? You definitely could. If I'm saying the whole thing on the left is equal to the whole thing on the right, well, I could take parts of the left and say they're equal to parts of the right. And that's what we're saying with the triangles here with CPCTC. If I say that this entire triangle over here is equal to this entire triangle over here, then I could definitely pick out little parts and say, well, then that angle is equal to that angle, right? So that's what we're doing with CPCTC. We're going to eventually say that the triangles are equal. So for instance, I'll keep with the colors I was using. Triangle CAB is congruent to triangle BDC. Okay, if I say that, I'm allowed to pick out little parts. Okay, I would be allowed to then say that, I used pink for those. I would then be able to pick out parts and say, well, then angle A is equal to angle D because the entire thing is equal. And the way we would get here with the stuff that I'm given, I really just mainly wanted to talk about what CPCTC does. But the way we would get here is we were given some sides that are parallel to each other. We were given that side AC is parallel to side DB, AC and DB. We were also given that AB is parallel to CD, again with those arrows. So AB is parallel to CD. Usually when we see parallel, that's telling us that alternate interior angles are congruent. So with AC and BD, we could say that angle ACB is congruent to angle DBC. And with AB being congruent, or I'm sorry, being parallel to CD, we could then say that angle ABC is congruent to angle DCB, if I did that correctly. So we've got two sets of congruent angles, and then we also have that CB is equal to CB. No, I'm sorry, CAB is equal to CD. That was given to us with these tick marks given, okay? We need to add some reasoning to these angles. They're alternate interior angles. This was because of alternate interior angles. Then I have a case of angle, angle, side congruency. And again, because I said both triangles are congruent to each other, I'm allowed to pick on certain parts and say, well, that means those are equal too. That's the whole point of corresponding parts of congruent triangles are congruent. It's just saying, hey, well, the little chunks are congruent because the big chunks are congruent. That's all that really means.